Hello, everyone. We are on day 8. That's right. We made it. We are right on the home stretch. I figured out my Klipper issues from yesterday. So, following the instructions is where I went wrong. So, right here, I highlighted it. Exclamation PC13. Now, if we look at a SKR board, specifically the board I have, we look at PC13, they've remapped it on the version 2 board to PS on. So PC13, it's looking for the power supply on to communication, and that's not going to work because this is supposed to look for the microcontroller chip startup. Hey, Helge. So because I chose PC13 by following the instructions, it didn't work. What I did find was, and I don't know if I can change the size. I'll move it up here. Can I change it? How do I change the size of this? So that you guys can actually, zoom. Here we are. Control and mouse wheel. All right. Oh yeah, that works well. All right. Yeah, all right. So what I found was if you open up the printer file for the SKR Mini V2, the GPIO pins to set the startup are PA14. Now, I looked through this file and saw this, but I was following these instructions. Now, these instructions are for the V1.2 board, not the 3. And so I went digging just to understand what the heck this pinout was and how it communicated and how it related to this. So it was a little bit of a rabbit hole, but I ended up opening up the pins file. And so let me find the pins file. So I opened up the Marlin pins file, and then I did a search for PA14. And lo and behold, on the SKR V2, it's USB Connect pin. And on any other one of the E3 boards, it's PC13. So there you go. So it's looking for the USB Connect pin. So if you are setting up another board that is not, let's say, an SKR board or whatnot, and you are trying to stand up Klipper and you want your serial port to be active when it communicates with the Raspberry Pi, you have to look through a pins file or know what the USB Connect pin is for that board, and then it'll stand up fine. So the screen, let me see if I can find it. Had it open. I have too many windows open. Here we are. You can't see it on there. I will tell you what. Well, doesn't matter. Not a big deal. So when you're going through this part right here. Let me go back to my PDF view. Which it doesn't look quite like this anymore. They've updated it, but when you're going through here and you have to specify your PC13, you'll have to specify whichever one is the USB connect pin for your processor that is on the board you're on, because depending on whose board you're using, they may have selected a different pin for that purpose. So that's where I went wrong, is I followed the instructions to the letter, and anyway, I got it communicating. I went through all this part. This is where I was having trouble when I ran this command right here, the ls command. That is supposed to show you the ID, but it wasn't showing me anything. It no longer connected. But now that I have the proper one in, I did get something similar to the command down below, and then up it came. And then I started working through this guide, and this guide, I gotta say, has some really good tips. So figuring out if my end stops were correct, that worked really well. You don't actually have to, you can use plain language like query end stops, but you can also use, what is it, M114, so your standard G code also in the terminal to get the responses to see if your stuff's open. So that is fine. And your logic for inverting is very similar to Duet. In Duet, you put an exclamation to reverse. So if it's normally closed and you want it normally open, you vice versa. If it was normally closed and you want it normally open, you add the exclamation, or vice versa, right? And then they had, you go through buzz the steppers. So this just moves the steppers back and forth in 1 millimeter increments, just to make sure that nothing's binding, everything's working, and that worked okay, no problem. And then I tried to home, and things didn't go well. Things went in the wrong direction. But this has a really good guide. So you've got your A/B motor. So I confirmed that my A/B motor were in the correct ports. So my B motor was in X, and my Y motor was in A for A. So that's good. So then I just had to figure out, okay, what's going on? So when I homed X, it was going the wrong direction. So X went this way, and so my B motor was inverted, so I switched that, and now it homes correctly. So that worked good. And then they had you go through and define your home point on it, and yeah, so that works really well. So if you guys are Octoprint people, and some of you might be, and have Raspberry Pis, one thing that's important is that I'm going to fire it up so I can get to the Pi, is that you know where all the files are located once because setting up Raspberry Pi is very straightforward. Where's my screen share? There it is. So we're just firing it up so that we can make sure that everything works. The only thing I haven't, so I PID'd the hot end. So I did fire it up and warmed it up and hot tightened and everything. So my nozzle's tightened. I haven't run filament through it yet. There's no PTFE on it yet, and I haven't tested the extruder, so we'll do that today. And I haven't tested the hotbed. So we'll have to do that as well. But what I thought we would do is I'm going to log into my Pi, use my super secret password, and no, it's not Raspberry. So when you're in your home directory on the Pi, if you do a list, this is where your config files are. So on the Voron website, they have a config file for the bed screw menu. They also have the printer config, which is where I got the figured out where the USB communication pins for the processor were. And then the other thing we have in here is the Klipper directory. So this is where you compile your Klipper to actually make the firmware or Klipper.bin that you rename to firmware.bin to put on your board. And I will just show you that now. CD Klipper. And I can't remember the command off the top of my head. I believe it is. Hold on, I gotta. There it is. Make menu. So the menu is what's loaded onto the Pi. So hopefully that's the font's big enough for everyone to see. Does that look okay? Yeah, see? So you enable the extra low-level options. If you don't enable that, you don't get the USB and whatnot. Microarchitecture. You can see they have quite a few, like there's your duet, right? There's your standard older stuff. There's your smoothie boards, STM32 boards. You can get go full Raspberry Pi if you want, Beagle, Linux, and so you can do a number of different things. So we're going STM32, and then when you go into there, they have all the sub processors. So you need to, if you are running like SKR2 or one of the spider boards, you would have to choose the appropriate board. So we're just doing the 103. Then you don't need that. You do have to change on this board your bootloader offset to 28 kilobit. Now, I'm not sure with the other boards what that is. Clock reference crystal, I didn't have to change that. This, if you look at PA11 and 12, if you look at the pins file on the actual board, you'll see the USB communication is PA11 and 12. So that has to match the specific board you're using and make sure that works. And we don't have to set the ID here because we would set it afterwards. And then you have to type in the appropriate haystack communication port. This is the USB port there. And then you would save it. And I'm just going to leave it, and I'm not going to save it because we did that. So I'm going to go back to my root of my home folder. So yeah, so there's all of our files, and if I go, for example, and I open up the printer.cfg and super secret password. So right here in the file, that's where it told me what I needed to do. So if the printer you are looking at building has a recommended board, you can get this. This I got directly off of the Voron site. And this basically is kind of equivalent to your pins file in Marlin. This is what tells all the commands how to communicate with the board. So you've already put the basic one-to-one mapping. That's what we would have generated with that config file to create the bin file. So that's the one-to-one mapping that this is going to communicate with. So, but this you can directly edit here. So like if I wanted to reverse my stepper, I could just put an exclamation mark there. And so this is all your settings for your silent steppers and everything. But the beauty of Klipper, and I'm coming around to it, is I don't have to recompile. I just restart the firmware and it's done. So that is really kind of cool. You can put your hot end settings in here. If you change your thermistor, or if you PID it, you can put it all in here, and then again just restart the firmware. You don't have to recompile. It's literally, it's a text file you change. So it makes things super easy if you want to upgrade your fans. All that startup parameters are right here. So you don't need to recompile every single time. So I'm really coming around. I'm liking it so far. The biggest problem I had was getting the board to communicate, and that again was just not knowing the microcontroller startup pins that it was using for the USB, which now I know. If you run a save, so you can save your config when you're running, it will at the end of the file put some of your parameters. It also creates another file. You can see this was created yesterday at 2:06 in the afternoon. So it creates a secondary file so that you can roll back changes if you need to. I don't know if I've looked in the bed screw one, so let's look at that one. Okay, so I think this is if you have a screen, and I don't have a screen on here yet, but this is for allowing you to automatically adjust your bed screws, so you can measure and it'll move your bed to where you need to go. So that's kind of cool. The other thing I haven't investigated yet, I'm going to go to my main view. The other thing I haven't investigated yet is an accelerometer. So I do have an accelerometer, and I can stick it to the back, temporarily put it on, and then find where my harmonics are with the sprinter, so I can kind of push it to the limit. So I'll do a video on that because I'm pretty interested in that. So we are pretty much ready to try to heat up the bed. Let's see if my printer is online. So I'm going to switch. Let's see if we can connect. It connected. All right. So currently we have temperature readings. So that is good. I have not tried the bed yet. So let's heat the bed let's heat the bed to 90 and see what happens. All right. No smoke. The silicone pad is getting warm. Ho-ho. I'm gonna no smoke, so I'm glad about that. So it is getting warming up. I even have a door, guys. Look. So I haven't built the top hat yet. That's on my list. I think I want to do the top hat purple. Maybe some purple, some green. I think purple would look good. So I think I might do purple for the top hat. But I got my enclosure on. And then once I get the top hat on, then I'll be able to print ABS. Stig, you weren't here earlier. I did heat up the hot end yesterday offline once I got some of the other stuff figured out, and I did hot set the nozzle. So it is nice and snug against the heat break. So I haven't ran any filament through it yet, so no PTFE in it yet. So we'll have to do that, and we'll do that today and troubleshoot. The bed is at 60 degrees. Wow. The silicone mat is at 60 degrees, and the bed, man, it takes a little while to get that the aluminum plate. It's quite thick. What is it? I want to say it's like 6 mil. Where's my calipers? I have a magnet and stuff on it. So it's 8 mil now. So I think it's 6-ish mil aluminum plate. So it's going to take a while to heat that sucker up. I hope we're just minutes away from the first print. Well, while it's heating up, what we can do is I can show you that the movement works. See? Ah. It's a little loud. I don't know if I've got silent mode on. So I'll have to work on the steppers. I'm not sure if that's just the inherent loudness of the belts. Maybe I have them a little too tight. But it did home. Now we'll have to level it because the offset definitely is wrong. It's a little too far away from the nozzle. But I want to get the bed warm first. Ooh, there, nice. It's definitely heating up now. So it's at 82 degrees. Now, one thing they do suggest is that I PID the bed, which I have not done. Let me find it here. There we are. So what they want you to do is they want you to open up a terminal, and they want you to run this command: PID calibrate heat bed target 100. So let's start the PID on that. And all right, so right now you can see it's increased the temperature range to 100, and you can't see that, but you can now. So and then on the terminal view, I ran this command. Now, I'm sure you don't need to necessarily run it in plain English like that, but I think that's a Klipper thing, is they make it a little easier for people to understand. You could run the standard, what is it, M301, if I remember correctly, to PID it. So, but this works. And so this takes a few minutes to get up to temperature. Oh man, whew. It's toasty. It's toasty. Definitely AC beds do heat up pretty quick, I gotta say. That was pretty impressive. So once it gets to the temperature, it'll ramp as per normal. And away we go. Yeah, it moves pretty nice. So we've got our thumb screws on the bottom here, which are just wing nuts. Originally they had spec'd some really nice brass turning knobs, but these will work fine. That's just what came with this kit. We've got let me just transition here. So right at the back here, let's see if I can get a view from this one. Let's see if I can get, yeah, that'll work better. So right down there's a little screw right there that we can adjust the offset from the end stop. So we can adjust that, plus the bed knobs, right? So they just give you those in this kit. So we can adjust it and get that going. I have some PTFE tube. It's just the white stuff, which should be good enough for our purposes. We got the extruder pocket watch right at the back there. You can see at the top of the unit there. The pie sitting at the back. Yeah, so it is looking like a printer. Let's go back to my screen share. And yeah, there we go. It's PIDing. You can see the waviness of the heat bed. So it's still going here. I'm just going to refresh this too so we get more lines. We'll suppress that. So there's my command. We'll wait. Don't need to see, you can see all the temperature messages as it's adjusting, but I like suppressing those so that we just get the commands. And so now we're just waiting for it to finish. It's just, that's pretty smooth curve, I gotta say. It's not too spiky. And you can see just with the door closed, the hot end has actually risen a bit. The hot end has just, it's at 30 degrees and it's not even on. So definitely the heat bed is working. Oh, and it just went off. So now if we go to the terminal, there is our commands for the PID. So now if we run this command, it saves it, reboots it, and then reconnects. So it saves it to the command, and we can go back to here. And if I go, you can see there's a new config file here. And if we look at that, it's basically your same config file. But if we look through here and find the, so this was the PID I ran the other day. And then now if we find the bed, and there's the PID settings. Now if we go back to our terminal, it was P was 40.404. So that's not 40.404, but I think it's maybe near the bottom where it adds it. Yeah. So those are the extruder. Where's the hot? Where's 40.404 or a bed? Let's see. Can we find? Where is? Not found. Interesting. Oh, unless it put it in the printer config. So let's go to the, because that might be the old printer config that it backed up. So sudo nano printer dot config. So I think it backs up your previous config. So now if we go all the way to the bottom here, yep, there it is. The extruder and heat bed. Do not edit this block, it was auto-generated. So this is where we've PID'd the extruder, and there's the bed we just did. So perfect. So it actually takes your original config and backs it up with another name so you can roll it back. So that makes sense. So there you go. All right. So the bed is PID'd. The printer is ready to go. I guess we just need to do some tweaking here. Get some PTFE tube in. I don't know if I have. I do have a blade here. How long do I need this? Don't need it very long. Something like that. We'll cut some PTFE here. And yes, I'm not using a scientific method. This is not a sharp knife. That looks pretty good. That one looks pretty good too. I think those pass. That one, clean up a little bit. All right. Pull the clip. Get that seated real good. There we go. That is our extruder. Get that in there real good. All right. Now, one thing they did suggest was put a little PTFE in the bottom here so you could feed your filament in. No, I don't know what that is, but we're going to. I can't do that from here. All right, there we go. I just fixed that spam that we got. All right, so now I think we are good to give this a shot here. I do have to level the bed. And there's a little spot here to kind of feed a PTFE tube in, so I'm just going to cut a chunk of this off just to make it a little easier. Oh, the backside of the knife is way sharper. All right, let's see if we can. I don't think that's big enough. They say put one in, but I don't think it's friggin' big enough to do that. So that's not going to work. We do need to put on spool holder, and this is their spool holder. You take PTFE and you run it through here. Yep. Let's see. There, that works better. And then you cut it off. Then you run another one through here. Like that, and then you cut that one off. Don't cut yourself. I recommend not cutting yourself. Don't drop your knife on your foot. There we we go. There we go. Now, put that there. And I need a screw to mount this, and then we can, well, what do they recommend for that? For a screw. M3 by 12. I should have some of those left over. M3 by 30, M3 by 25, M3 by 12. One right here. Look at that. All right, let's get this mounted up. Just there we go. Okay, so this is going to take a flip forward. And then gotta line it up correctly. All right. There we go. We got the spool holder on. Now I need some filament. All right. What filament should I use? This stuff's convenient, so we will use this. Okay, it's inserted, but I'm gonna have to heat up the hot end here. Oh, if I can find my OBS, yeah, here we are. I'm gonna switch to. I'm gonna have to heat up the hot end here. Where did my... All right. So let's go 60 for for the bed for now, and then we'll do 210 for the hot end. And it's the fan started, so that's good. Let's see if I can get the back view. There. So we'll see if we can get the filament moving in once the hot end heats up. I'm not sure if the actual motion of the extruder is the correct direction, so we'll see if it sucks it in. Filament guide? Oh, you mean from here? Yes, that's what the PTFE tube was going to be for, but I'm going to have to pull this off and make a little adjustment so that this, because the hole is not round, I'm going to have to make the hole rounder so I can put this in, and then that should fix that. How's our temperature? We're at temperature, so let's see if we can put in, let's say 25. Oh, it's going in. All right, let's try 100. Oh, it's feeding. It is feeding. All right. I can see it. It's moving up the tube here. It's going to be hard to see, but there's filament in the tube. All right. We're not quite at the hot end yet. Getting close. Good, stop. Yeah, so let me extrude some more. It's so close. There we go. Ho ho. There we go. Let's I think I've got a little bit of over extrusion happening. That's pretty thick filament. I think I gotta adjust my E steps. Because that's a 0.4 nozzle, so that's pretty oozy for a 0.4 nozzle, but that's all right. So now let's So we'll home it. And what I'm doing is they have an assisted bed leveling. So I'm going to try assisted bed leveling. So we'll go to 0.1. And that is definitely too far away. Definitely too far away. Alright, let's... I don't know if I can just make it up with this or if I'm going to have to... Oh, I think... I should adjust that screw at the back, because it is definitely way too far away. So I'm going to stop the leveling. I'm going to I guess it's homing. Alright, let's see if I can get down there to adjust this. Oh, I took it too low. Uh-oh. There we go. I took it too low, so I couldn't even reach the screw. So let's see if we can, if you guys can see this. So I'm just going to adjust the screw down here. Maybe. No, I think I need to come up a little bit. It's a little bit too low. All right, let's see if that works better. Yeah, there. Sorry about the seasickness. Yeah, that's fine. Okay, so now we'll go to 0.1. So it's still too far away. Okay. All right, that one looks okay. Okay, it just goes to 0.1, and then I can hit start, and then it homes it. This isn't a very good bed leveling assistant when there's only 1 point. All right, let's do this another way because the assistant doesn't seem to be doing what we want. Let's go G1 X. So this is 120 X 60 Y 0 0. That should put it almost over the screw. Okay, let's go to let's go to X 5 Y 120 no 110. It's pretty close. There we go. All right. Now we'll go to the other side. So X 110 and Y 110. Yeah, that looks good. And then we'll go to 0. Okay, and then it didn't descend my print. Oh. Okay, not bad. That seems pretty good. All right. I guess I'll check the center. I don't have a slicer set up either, so we'll have to see if we can get a slicer set up. All right, X, 60, Y, 60. That looks pretty good. And then that's not bad. Yeah, that was pretty darn close. Okay, so I do believe my bed is at 60, my hot end's at 210. I need to print something. I do have a feeler gauge right here. I like that tip. I do have a feeler gauge. So, it's probably a little bit closer than the feeler gauge, but I've always had good luck with the paper drag. If I have to, I can back it off a bit. All right, I need to slice something. So I don't mind you asking. So the kits here that I bought when I bought it, let's look it up. I can give you the exact price I paid for the kit. So the printed parts, a spool of ABS is, let's say, 25-ish bucks for maybe 30 for some good stuff. You'll need to buy a couple rolls to get the colors you want. Okay, so you're in it for let's say $50 right there. That just for the printed parts. The kit right now, let me just find I gotta find a browser window here. AliExpress. So I bought mine off of AliExpress just because there weren't any kits out at the time anywhere else. Now you can get them almost anywhere. But I want to tell you what I paid. I paid $600, so $590 Canadian for the kit. And that included everything you see here except the printed parts. And then my time to set it up. So I paid around $600, $690-ish total, I would say, with all the other little, I bought some extra wires and stuff. But if you go to, I'll go to one of my favorite places to buy stuff. And I'm going to, so this is, again, I'm not plugging them, but I go here, they have the Pi Zero kit. They're out of stock right now, but this is a whole kit, and this is $900 Canadian, and this is the LDO kit. the colors for the aluminum, you still have to get the printed part separate. So that's 900 Canadian. Who else sells them? Probably. I'm trying to think of a U.S. retail seller. The build volume is 120 by 120 by 120. So. I'm going to get the new version of Prusa because I think it has Prusa Slicer. I think it has the new Vorons in it. And I need the new Prusa Slicer because I only have the old one. So I'm going to close my old one, save my settings. We'll run the setup to Prusa and see if it has Voron in there. Boop, boop, boop. Yeah. Sure. Features. Yeah, yeah. Don't need those. Don't need those. That's good. Yeah, that's fine. Acknowledge. Sorry about the black screen. Yes, they have their new Pico board. So I'd be curious to check that one out. This kit also, just to be clear, it also included the Raspberry Pi. It included the motherboard, power supply, hot end, an actual V6 hot end, V6 heater block, heater cartridge, silicone heater pad. Like, besides being shorted a couple of square nuts, this kit, which was from Formbot, had everything I needed. So, which was pretty good. All right, finished. All right, let's see. All right, so here's my Prusa slicer. Let's update my profiles. That's fine. All right. Other vendors. Voron, yes, please. Ender 3, that's fine. Next. Voron. Ooh, V0 family. 0.4 nozzle. Perfect. Don't need that. Sure, we'll do all that stuff. Good, good. Yeah, that's good. No, that's fine. Expert mode, I prefer. File association. Oh, no, that's fine. V mode, expert, finish. Okay. So there is it's kind of interesting that they changed my Ender 3 to look like a Voron. Oh no, they didn't. That was just a glitch, I guess. Alright, so there's my Voron. Do we have a Voron profile? Do they have a... V0, yeah. We'll do 0.2 V0. Yeah, well, that should be fine because my filament is, yeah, 210. Okay, we're going to try this with whatever the defaults are. I guess I should print the traditional Voron cube, eh? So, Klipper, besides the one glitch, if you watch the first part of this video that I had setting up Klipper, it wasn't too bad. I would say it's way easier than Marlin, to tell you the truth. So they have a pretty good guide, but you have to make sure you watch the gotcha on the USB connection. All right, so let's find... I think I downloaded the Voron cube. I just got to see if I can find it here. Star.stl. Maybe cube. There it is. There is the Voron cube. All right. So if you've never set up Prusa before, you can go into here and set up Octoprint. And so this is going to be Hulk. And I have the 0.0. All the new kits are 0.1, so I have one of the older kits. 10.0.0.124. And then I need my API key. So I need to... I gotta find my web browser that had... my Octoprint. There we are. Go into here. API key. Copy. Paste. Test. All right. So now I can now slice this sucker. We'll go 5% infill. All right. Slicing's finished, and let's send it to the printer. All right. Did it go to the printer? It's there. Hasn't started printing yet. There we go. Maybe I didn't have it set to automatically start printing. Oh, it's extruding. Let's switch cameras. So exciting. So the next step, once you get your Voron done, is to submit your Voron for a serial number. So I'm going to have to go through the process of that, and then I can actually have a serial number on this thing. So that'll be the next step that I do. And yeah, it's printing. A Pi with 8 gig RAM is overkill, I do believe. Don't get me wrong, the Pi 4s are great. I'm running this on a Pi 3, but feel free to. Wow, man. I don't know what speed it was sliced at. I have no idea. I just went with the default settings. Holy cow. All right. So check this out. I'm going to switch cameras. It's set to 100 millimeters per second with 40 millimeters per second for perimeters. So we'll let it go. Why not? That's faster than I normally print, but let's see what happens. Oh, I think it's cooling too much. Let's see if we can turn cooling down, because I've got we'll see if I don't know, it's curling up, so not sure why that's going on. Well, let's see what happens. It might be a rough one. It's always, hey, it's the first one, right? Man, that's fast. All right, wow, we made it. So if you're already using Octoprint, getting Klipper is super easy. If you just follow on the Klipper site, the first thing they get you to do is install Octoprint, and it won't interfere with your regular printing. You can switch back and forth, so that's fine. So what you do is you run the setup. There's a git command to pull down the repository and clone it to your home folder on the root of your Pi, and then you'll run the commands, which will then basically you choose your board. I ran through that earlier, and I can actually, let me switch to, probably shouldn't do it while it's running, but basically you go through the setup for your board. You're going to choose some settings. It'll then, once you've got your settings right, which is like there's 4 settings, it will then output a file called Klipper.bin. If you say, I think you said you had an SKR board, so then what you do is you copy that, you FTP it off or SFTP it off. You take that file, you put it on the SD card that you're going to put into your SKR board, if that's what you're using. Then what you'll do, we got layer shift. I think it's going too fast. That's okay. I'll let it go for now. So then once you've got it on there, you have to rename it from Klipper.bin to firmware.bin, just like all your other firmware that you put on an SKR. And then you'll reboot your SKR board and it will now be in Klipper mode. I had the issue where the instructions I was following had the wrong communication with the onboard chip, so it didn't know that it was booted up with that firmware, so it didn't actually bring up the USB serial port, so Klipper couldn't find it on the Pi. So once you have to make sure that that part is correct. And at the beginning of this video, I kind of went through that on what I discovered. So please, I didn't, but it was a layer shift. So that's not due to an adhesion problem, but the curling on the corners is probably due to that. I should have cleaned it really good before I started. But it is printing fine. We'll see if there's any other layer shifts. It is quite noisy. It's even noisier when you open the door. Can't wait until I have a top hat. Even that just keeps the ambient temperature up, which is nice. So, I do have another bed though. So, because they didn't have LDO motors when I ordered mine, they gave me 2 printed beds. So I do have I can be printing and then I can swap beds, which is kind of nice. So I'll clean this sucker up. I might stick the sticker against there and then I can like store it somewhere. No, it's not that fast, but there's definitely, I mean, this is a completely untweaked printer. It could be that my belts aren't quite tight enough, right? That very well could be it. There hasn't been another shift yet, but yeah, it could be a belt thing. But that's not bad. I mean, I would have worked 24 hours a day to get this built, but I wanted you guys to come along, so I took my time. It took a little while to get some of the parts. I've got a few more things to put on. I got the handles to put on. And the handles, what's cool is, let's see if I think it's in this one. This one? Nope. Is it this one? Didn't think so. Here we are. We have little magnets, and you just glue the magnets in, which I might as well do right now. I got some crazy glue here. Let's put the magnets in. Come on. There we go. Uh-oh, too much glue in that one. Well, maybe that's good. Maybe that magnet won't go anywhere. But maybe my finger won't go anywhere either. Whoa. Okay, that did not sit flat at all. Why not? There we go. There we go. Magnets, so then that'll go on there. And then we've got these little holders. That the magnets fit into. Ah! Oh, but you got to get the there. You got to get the magnets orientated correctly, because otherwise they won't mount onto the rail on the side. Let's see if we got this one right. That one looks good. There we go. So little magnetic handles on the doors. We'll glue these in so we don't screw them up. I got more magnets if I did screw this up, so that's no big deal. So they give you 2 extra magnets in this kit. So the biggest thing I was short in this kit was the square nuts. So I'm actually short the square nuts for the side here. I think it's shifted again. It's looking a little rough. But we'll still let it finish. I want to see how bad it's going to look. That'll be my first official print. I don't know if you can see that, but my lights are strobing for some reason. They've been threatening to have rolling power outages because of the cold weather, and it's not where you want to be when it's cold, for sure. Alrighty. Well, thanks everyone for coming along for the ride on this. This is a fun project. I've got lots of other stuff to do, so I will make a video on this. I'll put some highlights from the actual build series in it. I'll go over my initial thoughts, and I'll also go over the Klipper installation at that point, and whatnot. So stay tuned for that, because I will go over all that. And then we'll do another video on the accelerometer, which is not part of the kit. I bought that separate, so we'll look at what it will take to tie that into the Pi's pins, and then allow us to tune the acceleration. I think once we tune the acceleration, then that'll really help out with the stuff. I think once I figure out if it's the belts, I mean, the belts don't seem that loose, but I mean, I'll double check that all the pulleys, I Loctited them all, so they should be good. So if something's slipping, I'll figure it out. And then, yeah, I'm looking forward to the accelerometer, and I think it'll go pretty fast, absolutely. So, yeah. All right. Well, thank you everyone for joining me this morning. Don't forget to like, and thanks for chatting with me while I'm doing the build. I'm going to let this monstrosity that it's printing finish. I will post it on our Patreon site, and I will also post it on GitHub or Discord. But thanks to Helge, who showed up earlier, and Stig's here. Thanks to Raymond and everyone else for supporting us on Patreon. It lets us do this kind of stuff, which is great, and we can kind of let you know what our results are, and hopefully you enjoyed the content. So give us a thumbs up if you like this, and we'll keep more of these kind of live builds coming, and we will have other content on the way. We'll be resuming our Sunday live streams in January. So our regularly scheduled live streams are Sundays at 10 a.m. Mountain Standard Time, and you can join us then. Where David and I chat about stuff in the 3D printing news, answer your questions, that sort of thing. Go over projects we've done like this and whatnot. So if you like that sort of thing, come join us there. And I will see you guys next time. Have a good evening, good afternoon, or good morning, wherever you are. And we will talk to you later. Hello, Dominic. It's working, but it's layer shifting. So we'll fix that later. All right. Talk to you later, guys.